All right, let's take a look at question number 3. We are to find y prime, where y is equal to the square root of secant x squared plus log base 2 of e to the 2x. All right, so we're going to be using the chain rule multiple times here, but we'll start by applying the chain rule to the radical function. And then when we're applying the product rule to the radicand, we are also going to make use of the chain rule also, okay? So chain rule for the square root, product rule for these two functions, and then we'll be using chain rule when we're applying the product rule in finding u prime and v prime. All right, so remember, if you have the function y is equal to square root of x, that follows that the derivative of y is going to be 1 over 2 rad x. Okay, so I'm going to apply that to this function first and looking for the derivative, but we are going to be applying the chain rule. So if I want to find the derivative of this function, y prime is going to be the derivative of the radical function evaluated at the inner function, which is a product of these two functions. So that's going to be 1 over the square root of the entire function. Actually, we have to put a 2 in front. So 1 over 2 root secant x squared plus 2 times log base 2 of e to the 2x. All right, so the reason why this formula is the case is because if you express this rad x as x to the 1/2 and you apply the power rule to it, you have 1/2 x to the negative 1/2, which can be expressed as 1 over 2 root x. But if you memorize this formula right here, you don't have to waste your time using the power rule for finding the derivative of radical functions. All right, so now we are applying the chain rule. We've differentiated the outer function. We're going to multiply this by the derivative of the inner function, secant x squared plus 2 times log base 2 of e to the 2x. All right, now we have to find the derivative of this inner function. Now to differentiate the inner function, we note that there are two functions, u and v, and they happen to be composite functions. So we have to apply the chain rule in finding v prime and u prime, okay? So let's extract u, find the derivative, and then extract v and find the derivative, then put the answers back into our final result, all right? So let's start with u. Our u function is secant x squared plus 2. All right, now we have two functions here. We can call this f of x, f, and then we can call the inner function g. All right, so if we say f of g of x is equal to secant x squared plus 2, the derivative of this function will be f prime of g of x times g prime of x. All right, so let's call f of x secant x. That was the outer function. Then the inner function g of x is x squared plus 2. All right, now let's differentiate both. F prime of x, the derivative of the secant function, is secant x times x. And then g prime of x, the derivative of the inner function, is simply 2x. All right, so the derivative f of g of x prime, which is basically going to be u prime, is the derivative of the outer function evaluated at the inner function times the derivative of the inner function. Okay, so we see here that f prime of g of x is simply the derivative of f evaluated at the inner function g of x. So we're going to take g and plug it into the x's here. Okay, that's going to be f prime of g of x. So we're going to have instead of secant x tan x, we'll have secant of g of x, which is x squared plus 2, tan of g of x, which is x squared plus 2. Okay, and then multiply that by the derivative of g, which is simply 2x. All right, so this is u prime. Now that we have u prime, we want to go ahead and find out what v prime is. So v is also a composite function, is a composition of three functions. So let's partition our workspace. I want to see how much space I have to work with. So let's divvy it up right here. Okay, now we have v, as indicated earlier, is a composition of three functions. So v of x, v is log base 2 of e to the 2x. Okay, so since we have three functions, we can call v f of g of h of x. Okay, all right. So f of g of h of x is equal to log base 2 of e to the 2x. So let's start with the outermost function, which is a logarithmic function. So f of x is log base 2 of x. And then the inner function, g of h of x, is e to the 2x. Okay? Now, what is g of x? The outer function, g of x, is e to the x. That leaves us with h of x as 2x. All right, so let's go ahead and find the derivative of the three functions. F prime of x is 1 over x ln 2. G prime of x is e to the x. And then h prime of x is 2. All right, so we know what the derivative of three functions composed with each other is. So v prime is f of g of h of x prime. So that's basically f, the derivative of an outermost function, evaluated at the composition of the center function and the innermost function. The middle function composed with the innermost function times the derivative of the middle function evaluated at the innermost function times the derivative of the innermost function. Okay, so all we're doing is basically taking g of h of x and plugging it into f prime of x, and taking h of x and plugging it into g prime of x, and then we'll multiply it by h of x. All right, so that's all we're doing here. So the derivative v prime is going to be what? What is it going to be? It's going to be 1 over, instead of x ln 2, we're going to compose it with g of h of x. So it's going to be e to the 2x ln 2 times g prime of x will be g, instead of e to the x, will be e to the 2x times e to the 2x times h prime of x, which is 2. Okay, so that's your v prime. Okay, so now that we have u prime and v prime, we can now apply the product rule to find the derivative of u and v. We know what the product rule is. It's v u prime times u v prime. Let's go ahead and write that down. So if you find in u v prime, the product rule says that that is v u prime plus u v prime. All right, so let's go ahead and write it. For this problem, you're not expected to simplify. You can leave your final answer in its unsimplified state. All right, we know that in the denominator we have 2 radical of that function. Let's go ahead and write that down. So we have, let's make it sufficiently long. I don't know how big this is going to be, but I need to make room for that. So downstairs we have 2 times the square root. times the square root of um, secant x squared plus 2, secant x squared plus 2 times log base 2 of e to the 2x, right? So that's the derivative of 1 over 2 root u. Now we're going to, remember our goal was to multiply by the derivative of uv. So we're basically looking for uv prime, the derivative of these two functions. So that's when we are going to apply the product rule in finding the derivative of this piece, okay? So we're going to start with vu prime. So v is log base 2 of e to the x, that's v. So let's write that down. Log base 2 of e to the 2x. Yes, vu prime is this result we have here, so it's going to be 2x secant x squared plus 2 tan x squared plus 2. All right, so this business we have right here is, let's make sure we understand what's going on. This is v, and then this entire piece is u prime. We're just applying the product rule to the inner function, vu prime, okay? And then what are we going to add here? We're going to add plus uv prime, okay? So u is secant x squared plus 2, so times secant x squared plus 2. We can even look down here, this is u and that's v, okay? Secant x squared plus 2 times times v prime. So v prime is 2e to the 2x, the product of these two, divided by um, e to the 2x times the natural logarithm of 2. Okay, so there basically goes your final answer. This is u, of course. This portion right here is u, and this other piece right here, that's v prime. Okay. All right, so there goes the solution to question number 3.